Hello and welcome to this tutorial. In this tutorial we are going to create an assembly of the simplified steam engine that you see on the screen. We will use the assembly for workbench, and what assembly for enables you to do is you can animate the assembly as you can see on the screen at the moment. Alright, so with that said, let's get going. Okay, so the first thing you need to do is take the zip folder that's available on ClickUp and store it in a location in a newly created directory, or on your desktop if you like, as I'm doing it now. But make sure you have a clean working environment. Okay, so we will now extract the zip folder. Okay. Then with FreeCAD open, we're going to the assembly for workbench. Okay, and in the assembly for workbench, we will create a new empty document. Sorry, I see I've already have an empty document. So if this isn't in your, obviously when you open FreeCAD this won't be there, so you have to create a new document. In my case the new document is already created. I then click on create a new assembly container. Okay, and we can just recompute that. Okay, and now we can save our assembly file on the desktop where we've downloaded all our stuff inside FreeCAD. And what I prefer to do is to use caps lock for assemblies. First I give the name and then I give 6 digits indicating the date. It's 2022 0420. Okay, and I save it. Now with that done and with the assembly highlighted, we can create a new body. And inside the assembly for workbench, if you create a new body, it will ask you for a body name, and what I call this body is capital MS for master sketch. Body underscore capital MS for master sketch. Right, so with that done, with the body selected, we create a sketch on the XY plane. Okay, so now the master sketch, what it will look like is it will have the following shape. It's basically a very sparse schematic drawing of the mechanism. Okay, so we start at the origin. Let's just zoom out a little bit. Okay, roughly there, here, and we close the sketch. Okay, and then we add a few constraints. So we constrain this size to 35 millimeters, and we use this icon to constrain this length to 8 millimeters. Okay, there will be 1 degree of freedom, obviously. That's fine if we right click and we drag this. So this is going to represent our rotating steam engine. Okay, that's the idea of this master sketch. That's very simple. 1 degree of freedom, we're going to constrain it in a little bit. We can close the sketch. Okay, we can click this icon just to show everything on the screen. And what we will do now, we go to the assembly for workbench, and we will create a few LCSs, local coordinate systems. So what you need to do is highlight the body in the tree view, and then click on create a new coordinate system, and let's call the first one crank. Crank, let's call it LCS crank. You can say OK. We click this line over here. We say Z tangent to H. Okay, we're going to have a slight problem. What we first need to do is just hide these original LCSs. Okay, now we can go back in. Here we go. Alright, so the second point, that's why we need to hide them, is you now need to bring your mouse close to this, to the origin. Make sure you select the vertex and not this line or that line. Okay, it's on the second selection, and we select that line over there. And we say Z tangent to H. Okay, jump to XY plane and 3 points. We want Z tangent to H, but we want it coinciding with this vertex over there. Alright, so we can OK that. Close this. Okay, that's our first vertex. You can see it needs to be recomputed. Okay, now the second vertex will be is exactly the same way. So with the body selected, we click create a new coordinate system, and this one we will call Conrad. Okay, we select this line, tangent to H. Sorry, before we do that, the second, now we make sure we select that vertex over there, and we say Z tangent to H, and there you go. You can, if you rotate it, you can actually see that those two local coordinate systems are exactly where we want them to be. Okay, and now we need one here at the top as well, and we can OK that. We can recompute with the body selected, click new coordinate system. This one we will call cylinder, LCS cylinder. We say OK, we click this line, we say Z tangent to H, and it is now indeed at the vertex, so we don't need to select the second vertex, we can just OK that. Alright, so with that done, we can recompute again. Now we do need one more local coordinate system, so let us just hide that last one we created, because we want to, and you'll see in a minute what we want to do here. So what we do here is we say, we call this cylinder bearing, if you like. Okay, click this line over here, and then zoom in, make sure we select the vertex, Z tangent to edge. There we go, and you can say okay. There we go. So we've got our four vertices or local coordinate systems that we've created, and that's exactly what we want to do. Let us save this. Okay, next we now want to import this master sketch into our assembly, and how we do that is we can actually, there we go. Okay, so we can click on the body master sketch in the tree view, click and drag it into parts. Okay, now you can see it's in parts, and we can save our file again. Alright, what we now do with the assembly highlighted, we click insert a link to a part. Okay, and as you can see here, the first part of my name is unnamed, okay, which is not what we want. Okay, so we can cancel this first and close the file. Open it again. Let's stop. Simplified steam engine. Okay, let's try now. Now you can see the name is Simplified Steam Engine 220420 hashtag body master sketch, which is exactly what we want. Okay, here we go. Insert. We now need to select LCS 0, and we want to link that to our LCS origin. Okay, there we go. So we can save that. Now the next thing we do is we open our main bearing. Okay, let's just give it a minute to open. Right. Okay, and now we do our insert test check, and there you can see main bearing, and there are three possible bodies that we can import. The one we want is this body 002. We don't want the main body main bearing blank. We also don't want body helix, we want body main bearing. Okay, so if we click on that and we say insert, okay, now we need to select our we can either do the parent assembly or the master sketch, so it's up to you really. We're going to use the master sketch quite a bit, so let's stick to that then, and we want to link the LCS1 to the local coordinate system 0 in the master sketch. Okay, if we rotate it, yes, that's exactly what we want, so we can okay that. Okay, save. Okay, so the next thing we do is we open the cylinder bearing. Okay, we go back to the assembly. Sorry, I see I've actually what I usually do is I add the word ASCII, which is my abbreviation that I use for assembly. So let's just save that. Yeah. So what we yes, okay. Let's delete those two files. There we go. Okay, so now we just check again. Yes, so there's a cylinder bearing body and body cylinder bearing, which is the one we want. We insert it. Yes, LCA cylinder pivot is the one we want, and in the master sketch, cylinder bearing. Okay, and now we need to tilt it, and if you look at this red axis, that's the x-axis, so we want to rotate it about the x-axis. Here we go. I've clicked it 3 times, rotate 90 degrees about the x-axis. Okay, there we go. Now the next thing we will insert, let us just save this quickly. Okay, so we file open and we will insert crank assembly. So we first open the crank assembly, go back to our simplified steam engine ASCII, and we do our test. Crank assembly is there. We insert it. The LCS origin is correct. We go to the master sketch and we say LCS crank. Okay. Now we need to orientate it correctly. So once again, if you look at this red axis over here, that's the x-axis. So we rotate about x, and I think yes, that's correct. We only have to rotate it through 90 degrees, and what we want to do now is we want to translate it. It's the blue lines, a blue axis, so that's Z. No, let's try Y. Yes, it's Y. Okay, so if we move the or translate the crank ASCII minus 15, okay, now it's in line with this flange. We have to translate it another another 20,55. So this will be minus 15 minus 20,55, so it's minus 35,55. Okay. Yeah, I've realized now that there is a slight mistake here, because the piston conrod, or the conrod pin, is not aligned with this dowel. There is another 90-degree rotation that's needed here. So what you can do, if you've made a mistake, is just you can right click and delete. Okay, and then just insert it again. Let's try again. So it's the crank assy, we inserted. LCS origin is the correct one. Body master sketch, crank. Okay, we will rotate about, I think it's X, yes, and we will yes, there we go. So we also need to rotate about Y, not Y, and it's Z. There we go. Now it's right. Now you can see that the crank pin is in line with this point over here, and no, it's not Z, it's Y, sorry. So it is what we said earlier, minus 35.55. Okay, that's perfect. Alright, so let us now, we can okay that, and we can say file save, yes. Okay, so we want to check if our crank is actually rotating as it should. So what we can do is, in assembly 4, we go to this icon over here, add a variable. So we click on that, we give the variable a name such as crank angle, we give it some arbitrary value, can be 30, doesn't matter, anything will be okay. Right, and what we now do, okay, you can see the white tick in the blue circle, we compute that, and we go to our body master sketch, okay, and we click on this icon over here, fix an angle. That's the angle we want to constrain, and we start typing in V for variables, dot, and then you start typing C for crank angle. You can say okay, and you can say okay, and we can close it. Alright. Now we can see if our model actually simulates. So we can select the begin range of 0 for argument's sake. The end range is 360. We want it to loop, that's fine. And the step size we can make 3 degrees, otherwise it's quite slow. And then you can say run. And it runs successfully. Okay, let us stop that. you can, once the animation is not running, you can actually, by moving the slider, change the value of the variable. Okay. Right, so the next step is we will insert the cylinder assembly, so we can hide some of these things, just minimize them. Let us recompute. Okay, so we will say file open cylinder assembly. Okay, go back to our simplified steam engine assembly, click on the assembly, click insert a part, and there you can see cylinder assembly. We inserted the LCS origin is correct, attached to master sketch cylinder. Okay, now we need to orientate it correctly. So it will be, if you're not sure, you can I've rotated it about the X, which seems to be working fine. Click the Z also twice because we want those holes at the top, and oh, that looks okay. Right, now we just need to offset it a little bit. Sorry, I'm not right. This should actually be, this is completely the wrong location. So we will have to, I think it's Y. There we go. Now it's in the right orientation, and we want to now move it along Y, and we want to do 20.5 in the negative direction. So we type in 20.5. Okay. Okay, that. Let's save it. And we can once again check the simulation, or the animation rather. And there you can see our cylinder is behaving as it should. Okay, we're making good progress, so let's quickly finish it. We complete our parts. Okay, so we say file open, and we want to import the piston conrod assembly. Okay, we go back to our simplified steam engine assembly. Okay, import piston conrod. Okay, the LCS origin is correct. We want body master sketch. We want LCS conrod. Okay, now we just need to orientate it. Okay, let's try Y. No, it's not Y. X. No, also not X. If you see you've selected the wrong direction or rotation, just click it another 3 times to to get it back into its original orientation. So it's Z. There we go. Now that's correctly orientated. And yes, it's Y. Okay, so now let's just see the distance. We want to go minus Y. Let us just see. It looks like it's too much. (41,5). That looks like, okay, so it's minus 41,5. And we say okay. File save. Yes. And let us animate. Okay, so that's exactly what we want. Yeah, that's what we want. Great. So let us stop that. Okay, so if you want to, you can neaten up your assembly by hiding these LCSs. It's not a problem. You can also hide the body master sketch here in the assembly, and just remember to hide it also. Why is it still visible? Oh, I know why. Okay, so the body master sketch in the parts, you can actually, you can also hide that. Let's just hide it. I can't delete it. So let's just hide it. Okay, and as I said, what you can also then do is just open each of these. And select the LCS and press spacebar. Okay, so with that said, we can once again save it. Then let us go to our desktop. Right, and then for you to submit, you need to compress the complete directory